Example 3 says answer the following about inverses. So is f of x equals x squared invertible? If so, where and find its inverse? So the first thing we can do is we can check if it's 1 to 1. So we can do that by graphing. So the graph of x squared is on the Graphs You Should Know sheet that is available on both of the websites where the packet is. So this is the graph of x squared. So if we look at it, well, it's definitely a function because it's going to pass the vertical line test, but it's going to fail the horizontal line test. So it is not 1 to 1. So just as is, we would say, no, it's not invertible. It's not 1 to 1, right? However, if we restrict the domain, we can find an inverse. So technically speaking, we can do any domain restriction we want to reduce this down to a 1-to-1 function. So before we decide what to do the domain restriction on, let's actually sketch what would happen if we just took the function as is and reflected it over the line y equals x. So we'd take this parabola and it would turn it on its side. So that's what it would happen visually if we try to do it, and you can see that this would not be a function because it would fail the vertical line test. So let's look what would happen if we just, let's say, didn't know the graph of this function and we tried to find its inverse algebraically. So we just assumed it was invertible. So the first thing we would do is we would start with y equals x squared. Then we would switch x and y and try to solve this for y. When you solve this for y and you take the square root of both sides, you would actually get plus or minus the square root of x. So that's your first tell algebraically that you have a problem, because you didn't return one equation, you actually returned two equations. And if you look at the picture where we flipped, y equals positive square root of x is this part of the graph, and y equals negative square root of x is the bottom half of the parabola. So we can't invert it unless we do a domain restriction. So typically when we do domain restrictions, we want to retain as much of the equation as we possibly can, or as much of the graph, so that way it accommodates as many values of x. So if we look at what the actual issue is here, it's really this turning point. As soon as the graph makes this turn, it's going to fail the horizontal line test. And we can see here when we flipped it on its side, right, it's really the turn is what's creating, right, everything above and below is what's making it cease to be a function on this end. So there's two possible inverses we could come up with. We could say, well, f inverse of x could be the square root of x if we restrict the graph of x squared to values greater than or equal to 0. So if we only take the right side of this parabola, then the inverse would be the positive square root of x. Conversely, we could only accept the left side, if we restrict the domain, right, to the left side. So here, if we only looked at this side, this would make it a 1-to-1 function, and its inverse generated would be the bottom half, and then if we only took the bottom half, we could see it would be a function. So by doing a domain restriction, we could find an inverse, but on its own, it is not going to be invertible. B says, well, what about the graph of x minus 2 squared plus 5? So this is a parabola that is shifted to the right 2 places and up 5 places. So it's still a parabola. We're still going to have the same problem. So what we want to do is we want to restrict it around that turning point. So the vertex of this parabola is at 2, 5, because this is x minus h quantity squared plus k. So x equals 2 is going to be where the turning point is located. And so if I take the left or the right side, then I can make it only 1-to-1 and invertible. So we can actually see how to do that by using our algebra rule here to calculate the inverse. So first, let's write the equation. Let's switch x and y. And now let's solve this for y. So I'm going to subtract 5 from both sides. And then I'm going to take the square root of both sides. So once again, I'm going to get plus or minus the square root of x minus 5 equals y minus 2. And then I'm going to add 2 to both sides. So once again, I've come up with two equations. The positive case is going to be for values to the right of 2, and the negative case are going to be values to the left of 2. So the function is not 1-to-1, but f inverse of x is 2 plus the square root of x minus 5, for f of x when x is greater than or equal to 2, and f inverse of x is 2 minus the square root of x minus 5, for f of x when x is less than or equal to 2. So once again, if we restrict the domain of the original function, then it becomes 1-to-1 and invertible. So what can we say about the invertibility of quadratic functions? They are only invertible if we restrict the domain around the x coordinate of the vertex. All right, and so we don't really need to say they're only invertible. I think the better way of saying that might be they become, right, invertible if you do that. So technically speaking, there's more than one way to make this 1-and-1, but the biggest possible domain you can have is if you restrict it around that vertex.